Hello, my dear students. In the last class, I explained principal stresses, how to find the normal stresses or shear stresses when it is subjected to one direction. Today, we will discuss about stresses on an oblique section of a body subjected to direct stresses in two mutual perpendicular directions. Okay, let us consider this figure. Okay, you can see here stresses are acting in two mutual perpendicular directions, sigma x in x direction and sigma y in y direction. Right? Here, let us consider a rectangular body of uniform cross-sectional area and unit thickness subjected to direct tensile stresses in two mutually perpendicular directions. Okay, along x-axis and y-axis. Sigma x is in x-axis and sigma y is in y-axis, and this AB is an oblique section and stresses are induced like this. And finally, what you have to find, normal stress and shear stress. Normal stress is developed like this and shear stress is like this. Okay, now let us consider an oblique section AB inclined with x-axis, that is with the line of action of the stress along x axis, termed as a major tensile stress. Okay, on which we are required to find out the stresses as shown in the figure. Here, let us consider sigma x is tensile stress along x axis, and it is also termed as major tensile stress. Okay, along the x axis it is considered as major tensile stress, and sigma y, that is tensile stress along y axis, also termed as minor tensile stress, and theta is the angle which the oblique section AB makes with x axis in the clockwise direction. Okay, this is just an assumption. Then you have to consider the equilibrium of the wedge AB, this one ABC. Okay, and we know that horizontal force acting on the face AC, that is Px is equal to sigma x into AC, and vertical force acting on the face BC, that is on y axis, Py is equal to sigma y into BC. This you have studied in engineering mechanics, how to resolve horizontal force and vertical force. Apply that equilibrium theorem and you write the equation like this. Okay, then you have to derive. In the last class also I have told that derivation is not important. You have to just remember the final formula. Okay, then resolve perpendicular, the forces perpendicular or normal to the section AB. You get like this Pn, and this is tangential Pt. Get, then simplify this. The final one is sigma n, that is normal stress across the section AB is equal to sigma x plus sigma y divided by 2 minus sigma x minus sigma y divided by 2 into cos 2 theta. This is the formula to find normal stress. Okay, sigma n, this is equal to sigma n. Final formula, you have to remember this. Sigma n is equal to sigma x plus sigma y divided by 2 minus sigma x minus sigma y divided by 2 into cos 2 theta. Next, you have to find tangential stress or shear stress. Again, derive and simplify. Final formula is this. Okay, tau or shear stress or tangential stress, that is equal to sigma x minus sigma y divided by 2 into sine 2 theta. These two formulas you remember to solve the problem. Okay, sigma n is this, and tau or tangential stress is sigma x minus sigma y divided by 2 into sine 2 theta. Okay, next, so I have written here finally, normal stress on the inclined plane is given by this formula. Sigma n is equal to sigma x plus sigma y divided by 2 minus sigma x minus sigma y divided by 2 into cos 2 theta. This sigma x is stress in the x direction and sigma y is stress in y direction. And then shear stress on the inclined plane is given by tau is equal to sigma x minus sigma y divided by 2 into sine 2 theta. Again, sigma x is stress in the x direction and sigma y is stress in y direction. Theta is the angle. Okay, and also it will be interesting to know from the equation that shear stress across the section AB will be maximum when sine 2 theta is equal to 1 or 2 theta is equal to 90 degree or theta is equal to 45. So when you substitute that in the equation, you get tau maximum is equal to sigma x minus sigma y divided by 2. If you substitute in this equation, okay, sine 2 theta, that is equal to 1. And so 2 theta is equal to 90 degree, theta is 45. So you get this is becomes 1. So tau maximum is only sigma x minus sigma y divided by 2. See the difference. This is shear stress. Total shear stress you have to find using this formula, but maximum shear stress is only sigma x minus sigma y divided by 2. Okay, then now the resultant stress may be found out from this relation. This is same like first case, sigma r resultant shear stress is equal to sigma n square, that is the normal stress, plus tau square. Okay, so remember these four formulas, then you can find can solve the numericals. Let us consider one example. Okay, a point in a strained material is subjected to two mutually perpendicular tensile stresses of 200 MPa and 100 MPa. Determine the intensities of normal shear and resultant stresses on a plane inclined at 30 degree with the axis of minor tensile stress. This is given here. What is given? Tensile stresses of 200 MPa and 100 MPa. Okay, so tensile stress along x-axis, first one you consider as x-axis, that is 200 MPa, and tensile stress along y-axis, that is 100 MPa. And you have angle is given, that is angle made by the plane with the axis of the tensile stress theta is equal to 30 degree. Right, so we'll use the formula directly. What is that? Normal stress on the inclined plane, that is given by the equation sigma n is equal to sigma x plus sigma y divided by 2 minus sigma x minus sigma y divided by 2 into cos 2 theta. So use that values. What is sigma x? Sigma x is equal to, it is stress developed in the x direction, that is 200, sigma x is equal to 200 plus sigma y is equal to 100 divided by 2 minus sigma x again 200 minus 100, sigma y is 100 divided by 2 into cos 2 theta. Cos 2 into theta is equal to 30 degrees. Simplify this, you get sigma n is equal to 125 MPa or 125 Newton per millimeter square. Okay, this is normal stress. Let us then find shear stress. How to find shear stress? We have the formula tau is equal to sigma x minus sigma y divided by 2 into sine 2 theta. Direct substitution here. What is sigma x? Sigma x is 200 and sigma y is 100 and divided by 2 into sine 2 theta. Theta is 30 degrees. Simplify, you get tau is equal to 43.3. Okay, next what you have to calculate? You have to find resultant stresses. How to find resultant stress? We have formula sigma r, that is equal to square root of sigma n square plus tau square. Use that. What is sigma n? Sigma n is 125. So square root of 125 square plus what is tau? tau is 43.3. So 43.3 square. Simplify, you get 132.3 MPa. Okay, very simple. Here, direct substitution. Only you have to remember the formula. It is different for different cases. Hope all of you understood. Let us go to the next problem. Okay, the stresses at a point of a meshing component are 150 MPa and 50 MPa, both tensile. Find the intensities of normal shear and resultant stresses on a plane inclined at an angle of 55 degree with the axis of major tensile stress. Also find the magnitude of the maximum shear stress in the component. Okay, what is given here? Tensile stress, both are tensile stress. Along x-axis is 150 MPa and y-axis is 50 MPa. Okay, and angle made by the plane with the major tensile stress is 55 degree. Okay, we'll use that formula. Same, a normal stress is equal to sigma x plus sigma y divided by 2 minus sigma x minus sigma y divided by 2 into cos 2 theta. Okay, substitute what is sigma x 150 and what is sigma y 50 divided by 2 minus, again same, simplify, you get sigma n is equal to 117.1 MPa. Okay, then we'll find what is shear stress on the inclined plane. What is the formula? Tau is equal to sigma x minus sigma y divided by 2 into sine 2 theta. Right? So substitute what is sigma x 150 and what is sigma y 50 and divided by 2 into sine. Theta is 55 degree. So simplify, you get 47 MPa. What is next? Next you have to calculate resultant stress on the inclined plane. You know the formula, sigma r is equal to square root of sigma n square plus tau square. Substitute. What is sigma n? 117.1. What is tau? 47. Simplify, you get 126.2 MPa. Next, you have to calculate what is the maximum shear stress in the component. What is that formula? I have told that when it is the maximum shear stress, sine 2 theta is equal to 1. So, if you substitute sine 2 theta is equal to 1 in this equation, what you will get? Tau is equal to sigma x minus sigma y divided by 2. That's it. Okay. So, substitute the values. What is sigma x? Sigma x is equal to 150 and sigma y is equal to 50 divided by 2. That is equal to 50 MPa. This is the maximum shear stress in the component. Okay. Like this, you can calculate what is normal stress and what is shear stress and what is resultant stress and what is the maximum shear stress in the component. Hope all of you understood. If you have any difficulties, we'll discuss in the live session. Okay, thank you.